Okay, with DSL connections, we have service providers deploying DSL connections in the local loop. The connection is set up between the DSL modem and the DSL access multiplexer. The DSL modem converts Ethernet signals to a DSL signal, which is transmitted to the multiplexer at the provider location. The multiplexer is located at the CO of the provider and concentrates connections from multiple DSL subscribers. DSL is not a shared medium, okay? Dedicated. Each user has a separate direct connection to the multiplexer. So the connections, basically you have, this is a customer. Customer connects to the DSL modem, which converts the Ethernet signal to a DSL signal. It's an analog signal, I think. DSL is probably digital over the telephone lines. Right from there, we have our multiplexer. So this multiplexer, if we have multiple customers here, all their lines reach this multiplexer. Then from the multiplexer, we have a link connecting to the wide area network. So here, this is our CO. I think we already uh, defined what the CO is. Here, the DSLAM, DSL access multiplexer is in our CO. Then from here, it goes to the wide area network. So that is a typical DSL connection. Right, DSL and triple P. Now, triple P, that is a point-to-point protocol, a layer 2 protocol, which is used mainly for authentication and authorization purposes. So triple P offers authentication. Now, if I'm a service provider and I'm providing internet over DSL, and there is no way of authenticating who the users are, I think you run a loss because almost everyone with the telephone line can get access to to your services, if I can say. But because we now have triple P plus DSL working together, triple P offers the authentication and the authorization. I think which is very useful for service provider companies. So triple P can be used to authenticate the subscriber, can assign a public IPv4 address, provide link quality management features. I think the most important thing to understand when you hear triple P, CCNA, it doesn't go much deep into the point-to-point protocol, unlike Huawei. Huawei, I think there's a whole topic about these layer 2 protocols. What you need to know with respect to CCNA is what triple P is responsible for, and it is responsible for authentication and authorization. There are two ways triple P over Ethernet can be deployed. Right. So triple P we cannot easily deploy. We cannot deploy it. We can deploy it over Ethernet. Okay, let me rephrase. There are two ways triple P over Ethernet can be deployed. We have host with triple P, host with PP over Ethernet client. Then we have router with triple P over Ethernet client. This is supposed to be triple E. Uh, okay. Let me gather my thoughts. Just a minute. Mhm. Host with PPOE client, then router with PPOE client. Okay. All right. Let's begin with host with triple POE client. So this is very useful when you want to bypass the router. So you can see this network, the client is directly connected to the DSL modem. And authentication and authorization happens directly on the client's computer. So there is a software that is used. You have a software installed on your computer, which allows you to directly authenticate yourself as a customer, as a subscriber. Then the traffic is encapsulated with triple P over Ethernet. You can see triple P is over Ethernet. Then it goes to the DSL. The DSL then encapsulates with a triple P uh, packet. Then from there, it goes to the access multiplexer. All right. Very important to understand. Here, this is triple P over Ethernet. So the encapsulation is triple P encapsulated over Ethernet. And here, we no longer have the Ethernet. This is triple P encapsulation only. Right. So with host being a client, a triple P client, there is a software installed here which allows you to encapsulate triple P over Ethernet. Then your traffic goes here. Then it goes to the multiplexer. With the router as a triple P over Ethernet client, it means authentication happens here. Triple P authentication happens at the router. So traffic coming from your end devices, your computers, is not encapsulated with triple E in this case, right? Encapsulation happens here. That's why we have triple P over Ethernet here. Then from there, from the modem, it is only encapsulated with triple P. So the two ways which triple P over Ethernet can be deployed, one, you can deploy it on an end device itself. A software is used. Then the other one, it can be deployed on a router with a couple of configurations on the router. Then you can deploy your triple P, point-to-point protocol. Authentication, authorization. I think for CCNA, I've mentioned quite a lot of things. Not much to do with triple P CCNA. Right, cable technology. Like I said, I'm not familiar with this one. It uses coaxial cable. I think the only coaxial cable I've seen in my life is the one we use for our satellites, our satellite dishes. The one which goes from the LNB to the decoder. I think that's all the coaxial cable I've seen. I'm not sure it's the same cable technology that is being mentioned there, but cable technology. So instead of having a DSL modem here, we have a cable modem. Then here, instead of having copper, we have coaxial. Here, we have an extra, I think this is an extra device which converts whatever is coming from the coaxial line to optical fiber. I'm sure the reason is because over long distances, we cannot use the coaxial line. Then from there, we have the CMTS. With DSL, we had the multiplexer here. The CMTS, this is the cable modem termination system, all right? And it's responsible for communicating with the cable modems. So all other cable modems, they feed their traffic here. Then from here, it goes to the wide area network or your internet. So cable technology, DSL, almost the same thing. The only difference is one, instead of having copper wires, we have the coaxial cable. Instead of having the multiplexer there, we have the termination system. Okay, all the local subscribers share the same cable bandwidth. As more users join the service, available bandwidth may drop. I think that is a very important thing to highlight. Another difference, that is the difference between DSL and coaxial cable. So with the DSL, we had multiplexing, right? It means every line, every link is dedicated to a customer. Then when all those lines reaches the access multiplexer, they are multiplexed to go to the WAN. Because every line is dedicated, it means bandwidth is not affected by the number of customers added to the network. But this one, however, if another customer is added to the network, it will be using the same line. It means bandwidth per user drops. Right, optical fiber. This is more common here. I think this is the most common connectivity option. Is it most common? It depends. I think with businesses, definitely the most common. With everyone else like us, wireless is probably the most common. Right, fiber to home. Many municipalities, cities, providers install fiber optic cable to user locations. This is commonly referred to as fiber to the X. So we have fiber to the home, fiber to the building, fiber to the neighborhood. Uh, I know fiber to the home, FTTH. So basically, your service provider brings fiber to a place near you. Internet-based connectivity. I don't think there is much to explain about optical fiber. FTTX can deliver the highest bandwidth of all broadband options. Wireless internet-based broadband connectivity options. Okay, we are done with wired. With wireless, we have municipal Wi-Fi. As I said, I've never used this one. I don't know if it exists here, but it's there somewhere. We have cellular. This is your 3G, 4G, 5G, LTE. I've used 5G. I think 5G is almost everywhere now. Is it not? In Arara 5G is available. Then we have satellite internet, typically used by rural users in remote locations where cable and DSL are not available. I find this very funny because every Hararian is using or wants to use satellite internet. That's a problem. At some point, we're having a conversation. Why use satellite when you have fiber? And I think Zimbabwe is a very good study case. Everyone wants to use satellite internet. Interesting. Okay, then we have WiMAX. That is microwave. If you look at the towers, the cell towers, panenge ma antennas, ana net one, ana Econet. If you look at those cell towers and you see round things, that is WiMAX for you. Those round things are the antennas which are used for WiMAX. I think the big service providers, the MNOs, they use them to interconnect their base stations, but they can also be used to access the internet. I know of Telco, which uses WiMAX, and it offers their services to different types of customers. Okay, wireless internet based. Right, then we have VPN. Now we are done with internet based. Most of the technologies we were discussing, they were probably private, except the internet, which is a public network. Now, VPN technology comes in to ride over the public network, which is the internet. If I want to connect over large distances, regional, it becomes very difficult to have all the type of connections that we just discussed. From your PSTN, you cannot have a PSTN that reaches America. Your PSTN is probably local. You cannot have a dedicated link or a least link that goes to America. If it's there, it's very expensive. You cannot have that. All right. You cannot have your wireless, your 3G, 4G up to America. You cannot. You can, but there are additional technologies which are being used there. Now, VPN is probably the cheapest of all the technologies summed up. so that you can have another office in America. It rides over the internet. So over the internet, tunnel is created using encryption encryption methods. I know of IPsec, you encrypt your information so that it goes over the internet, but no one is able to read that. Basically, that is what VPN is. VPN can be used to address security concerns incurred when a remote office worker uses broadband services to access corporate WAN over the internet. A VPN is an encrypted connection between private networks over a public network. VPN tunnels are routed through the internet from the private network of the company to the remote site. There are several benefits. Cost savings. Why cost saving? Because you are riding over the internet, over someone else's infrastructure. Right? That's why it's less costly. If it wasn't for that, to have a secure connection, it will mean a dedicated link. And that would be very expensive to have a dedicated link from here to North America. Security, encryption, and authentication as well, right? Scalability, corporations can add large amounts of capacity without adding significant infrastructure. The infrastructure is already there, the internet. When we talk of the internet, if I was in a normal class, I'll be asking, what do you think of when you talk of the internet? I'm sure you'll be thinking about connectivity, getting information. On the other side of that, the internet is the infrastructure itself, the infrastructure which allows you to share that information. Right. So when you talk of corporations can add large amounts of capacity without adding significant infrastructure. The reason why they are not doing that is because of the internet. Compatibility with broadband technology is supported by broadband services providers such as DSL and cable. Now, VPN are commonly implemented as the following: site-to-site VPN and remote access. Two ways, right? With site-to-site VPN, examples that we have. Okay, VPN settings are configured on routers. Clients are unaware that their data is being encrypted. So the routers between the two sites, routers at each end of the sites that we have, which are being connected, that's where the configurations are done. So that is site-to-site VPN. Routers, configurations at the routers, and the devices in the network. They're not aware that there is encryption which is happening at the router, site-to-site. Common protocols which are used. I know of IPsec. I know of GRE, which is usually used with IPsec itself. So I think it's IPsec. When you hear VPN, talk of IPsec. Right, remote access. This one is a bit different. The user is aware and initiates remote access connection. For example, using HTTPS in a browser to connect to a bank. Alternatively, the user can run VPN client software on their host to connect to and authenticate with the destination device. So instead of being unaware that there is a VPN configured on a router, the user itself initiates connection to the VPN. A perfect example on my phone, I have an application. What's it called? Turbo something. Turbo VPN. Just a minute, let me see. Yes, Turbo VPN. I have an application, Turbo VPN. If I go there, I can be Googling from the United of America, right? That is a software which I'm using to create a VPN. So I am aware of what is happening with the VPN because I'm initiating that. So those are the two types of ways VPN is implemented: site to site and remote access. So you can figure if I'm connecting two branches, it's definitely site to site I'm using. But if it's an employee on a holiday trying to access information from the branch, they're going to use remote access. All right. And typical questions are just like that. Will they might ask you, we have an employee who is on a holiday and wants to connect to the HQ. What type of VPN are they using? They will be using remote access. All right. ISP connectivity options. There are different ways an organization can connect to an ISP. The choice depends on the needs and the budget. I think we already talked Joe Home. With a single home connection, there is only one link. Right? This is single, one link to the service provider. It provides no redundancy and is the least expensive solution. For our homes, no problem using that. For enterprises, huge problem. If this link goes down, everything goes down. You're homed with the same service provider. We now have two links. With the same service provider, we now have two links. That is your homed. Connects to the same ISP using two links. It provides redundancy. If one link goes down, the other one is still up. However, the organization loses the internet if the ISP experiences an outage. So if ISP goes down, then everything goes down. Multi-homed, the client connects to two different ISPs. This design provides redundancy and enables load balancing, but it is very expensive. So with this one, you are connected to two different service providers. Basically, that means two different links. So if this goes down, this one is always up. Very expensive, however. With dual homed, multi-homed, this is the most resilient topology of the four shown. The client connects with redundant links to multiple ISPs. This topology provides the most redundancy possible. It is the most expensive option of the four. And my wish is you work at a company like this one. You probably be getting paid as much as how expensive those networks are to run. Right, broadband solution comparison. Each broadband solution has advantages and disadvantages. If there are multiple broadband solutions available, a cost versus benefit analysis should be performed. Some factors to consider. Cable. Bandwidth is shared by many users. That's a disadvantage. Therefore, upstream data rates are often slow during high usage hours in areas with oversubscription. With DSL, it has limited bandwidth that is distance sensitive. Upload rate is proportionally low compared to the download rate. Fiber to the home, that one is perfect. I don't think it has disadvantages, that one, as compared to everything else on that list. This option requires fiber installation directly to the home. Probably cost of installation a bit higher, but I think this is the best option that you can have. Cellular mobile, with this option, coverage is often an issue, even within a small office or home office where bandwidth is relatively limited. Coverage definitely an issue. Evidence in our country. Municipal Wi-Fi. Hi, I can no longer talk of municipal Wi-Fi. We have satellite. This option is expensive and provides limited capacity per subscriber. Typically used when no other option is available. Right, I'll go through this option. Recently I experienced this one. Starling was saying we've reached maximum capacity in Harare. I think we can relate to this one. This option is expensive and provides limited capacity per subscriber. I think they improved their capacity and we've been able to add quite a number of those Starlink devices. Done. Thank you very much for your time. This is WAN Concepts for you. Hmm.